So down here I've got what looks like 3 whole packets, and on the right hand side is 26 sweeties, individual sweeties. Now these actually balance. If I put this in my scales on the left hand side and this in my scales on the right hand side, they balance exactly. So this looks like 3 whole packets, but actually over on the left it's 2 whole packets, and then this one that's been opened, and 1 sweetie is missing from there. So what I'm representing is this equation here, that we've got 3 whole packets, but well, we've got one less than 3 whole packets, 1 sweetie less than 3 whole packets. Okay, and over on the right, 26 whole sweeties. And I think to myself, well, okay, what on earth could I do then to both sides to help me work this out? And this time, it's a good idea to add a sweetie to both sides. If I add a sweet to the right hand side, there's now 27 sweets on the right hand side, but I can't just do it to one side, I need to do it to both sides. So what I'm going to do is I'm going to put this sweet back into the packet. Okay, so now it's 3 full packets. 3 full packets balances with 27 individual sweets. So there it is written down. We used to have on the left hand side one less than 3 whole packs and 26 on the right, but then we added 1 sweet. I put it back in the open bag, so now it's 3 whole bags, 3 complete bags with nothing missing over on the left, and on the right hand side 26 sweets, add 1 more sweet is 27 sweets. So that's what it looks like. Now the thing I'm going to do to both sides is divide both sides by 3. If I divide 3 bags by 3, I should end up with 1 bag. And if I divide this by 3, I'll get 9, won't I? Which looks like this on my scales. But looks like this when I write it with algebra. So that last step was 3 bags divided by 3 is 1 whole bag, but 27 sweets divided by 3 is 9 sweets. So what I've worked out is that each bag contains 9 sweets. It is actually true. When I started doing this, I thought, oh, well, what if different sweets weigh different things? Actually, they're so close that the machine has always packed in 9. For all the bags I've opened so far, I've counted them to make sure, and it is actually 9 every single time. There's always 9 sweets in a full bag. So another example, this time I'd like to solve this equation. So I'm solving 3x minus 4 is the same as x plus 14. And again, to solve an equation means, can you figure out what the x is worth? Spoiler alert, it's 9. We've already worked it out because it's the same thing. I'm going to use the sweets again, but let's pretend we don't know. My question is, once again, how many sweets are in the bag? What's x worth? It's going to be 9, but let's pretend we don't know that. I'll show you the steps that are involved in working it out. So here we are then, we've got the situation. It looks very much like 3 whole bags on the left is balancing with 1 whole bag and 14 loose sweeties, but that's not actually strictly true because these are sealed up. These are full bags, but this one here, you can see once again has been opened, and there's been 4 taken out of that. So that's not a full bag, right? There's 4 taken out of that. So it's my representation of this situation here. 4 less than 3 whole bags is the same as 1 whole bag plus 14. So that's my representation of that. Now again, think about, well, what could we do to keep both sides balanced? And again, it's adding some sweets. I'm going to add 4 sweets to both sides. So here's 4 sweets. Let's add them to the right hand side like so, but I can't just do that to one side, I have to do it to both sides. So here's 4 sweets. If I put them back in that bag that was open, if I replace those 4 sweets which were presumably eaten, I replace those, there we go, now it's 3 full bags again. So I've got 3 full bags, appears to be balanced with 1 full bag and 14 sweeties. Let's see how to write that. So when you add the 4 sweets to both sides on the left, adding 4 sweets just completes that bag. I used to have something which means 4 less than 3 full bags, but if you add the 4 back on, you've now got 3 full bags. Of course, minus 4 plus 4 is 0, isn't it? and that's why there's no number over here. When you add 4 to -4, you get 0, but it doesn't affect how many x's there are. It didn't affect the bags, did it? Whereas over on the right, similarly, it didn't affect the bags. If you add 4 individual sweeties, you've got 4 more sweeties than you had before. It goes from 14 up to 18, but clearly didn't affect the full bags. Next step then, to make this simpler, I think I will take away 1 bag from both sides. So that will keep it balanced. As long as I do it to both sides, then this remains balanced. Okay, so I've got 2 full bags on the left now, and if you count them, 18 sweets on the right, which is written down like this. Taking away a full bag is taking away an x. Now remember, I don't know what number that is, I don't know what x is, but I'm doing it to both sides. I'm taking the exact same thing from both sides, taking 1 bag away from both sides. So I'm allowed to do that because it's the same. 3 bags take away 1 bag is 2 bags. If you take away the bag on the right hand side, there's now no bags left. Notice how there's no x's down here now, but there's still all 18 of the sweets left. Okay. And the last step to try sorting this out is to just divide both sides by 2. So if I halve the left-hand side, half of 2 bags is 1 bag, and then half of 18 is 9. So once again, we have that 1 bag balances with 9. So 1 bag must have 9 sweets in it. And that's how it's written in algebra. 2 bags divided by 2 is 1 bag, 18 sweets divided by 2 is 9 sweets. Right, now for some examples where we're not going to have any pictures, we'll have no diagrams, we'll have no sweeties, we'll have no dominoes or dice or any of those things. We're just going to try working it out using the algebra. Okay, we can fall back on imagining them if you like. You can imagine some pennies or you can imagine some sweeties if it helps. But we're just going to do the algebra basically. Okay, so in this first question, we've got 12 times a mystery number, take away 9, is the same as 51, and we're trying to work out what x is. Now, the easy way, the inverse operations way, would be just to add 9 and then divide by 12. And I am going to do that, but to both sides. Okay, so I'm going to add 9 to both sides and then divide both sides by 12. Add 9, add 9. Let's do that first. Now this is quite easy over on the right hand side. 51 add 9, that's straightforward, that's just 60. But actually I claim that the left hand side is even easier. The whole point of adding 9 is it gets rid of the -9. Right, that was why we decided they're opposites. If you do -9 add 9, you get 0. So the whole point of adding 9 is it just gets rid of it, so there are no numbers anymore, there's no individual sweeties, but there are 12 packs still, 12 full packs still. Okay, next step is to divide both sides by 12. Now you would have thought hopefully to divide by 12 because this says mystery number times 12, so the inverse is divide by 12, but we're doing it to both sides, remember. Over on the right, that's easy. 60 divided by 12 is 5, but it's even easier over on the left. The whole point of dividing by 12 was that it gets rid of the times by 12. So it's just 1, isn't it? 1x is all that's left. Okay, so if you think of a number, times it by 12 and take away 9, then you would hopefully think that it's necessary to add 9 and divide by 12. But critically, we're not just doing 51 add 9 and then the result divided by 12. We're doing it to both sides all the time. And actually, the left-hand side is the easier one. When you do this, it's probably going to sort out one of these things. Adding 9 got rid of the -9. Divided by 12 got rid of the times by 12. So it's simplified as we went along over on the left-hand side. These do take a bit of practice. Please don't worry if it's going to take you several examples. It's not a problem. You can watch the video several times, come into the Google Meet and ask. I can give you more examples if you need. Let's have a look at this one. So 28 is the same as 2x plus 12. You could think of this as, I think of a number, times it by 2, and then add 12, and the result is 28. You could also think of it as if you had 2 full bags of sweeties plus 12 individual sweets, that would balance with 28 individual sweets. Okay, what would you do? I think I would like to take away 12 from both sides, because the opposite of adding 12 is taking away 12. But don't forget, we're doing it from both sides. Now this is quite easy. 28 take away 12 is 16. But it's even easier over on the right hand side. The whole point of taking away 12 is it gets rid of this plus 12. So we're just left with the 2x's. Think about it. If you have 2 full bags and 12 excuse me, if you have 2 full bags and 12 individual sweets, but then you take the 12 individual sweets away, you've still got the 2 full bags, but there's no individual sweets anymore. The opposite of times by 2 is divide by 2, so let's halve both sides. Divide by 2. And half of 16 is 8. Half of 2x is 1x. So 1x is 8. We've solved the equation. X was 8. Now, some of the equations you might do, it could have brackets in, but that's not a problem because you know how brackets work. So what I would do, if an equation has brackets in, just expand them first. Expanding brackets doesn't change anything, so you won't need to do anything to the right hand side. So okay, if I expand these brackets, 4 lots of x is 4x, and 4 lots of minus 2 is minus 8. So now my question is just like before. Now it doesn't have any brackets in it. So it really wasn't a problem, was it? If the question had brackets in it, just expand them first, and then you turn it into an easier question, one like we already know how to do. So you think of a number, times it by 4, then take away 8. The result is 20. How are we going to get rid of a minus 8? Hopefully you're thinking the opposite of taking away 8 is to add 8. But of course we do that to both sides. You add 8 over here, add 8 over here, then what you're going to get, I think, well, this is pretty easy. 20 plus 8 is 28. But over on the left, the whole point of adding 8 is it got rid of the minus 8. You've still got the 4x's though. Okay, remember when you add and subtract numbers, that affects the number. When you add and subtract x's, that affects the x's, but they don't affect each other. The number I'm trying to find has been multiplied by 4, so let's divide both sides by 4. Okay, 4x divided by 4 is 1x. 28 divided by 4 is 7. Now think of my last 2 examples as just extra. Don't worry if you've already got enough to be getting on with. In fact, you could even pause the video now or stop the video and start doing some questions. And then if you're finding them particularly easy, you could come back. So I'm just going to show you how to solve equations that have x on both sides. You could always do these another day, so don't worry about it. If you've got enough to be getting on with, then that's fine. But if I do want to solve it, I need to think about opposites, and I'll be doing the same to both sides. So, for example, I might want to get rid of the minus 6. If I want to get rid of minus 6, I'd add 6 to both sides. I might not be too keen on having x's on both sides. Maybe I want to get rid of some x's. You could take away any number of x's from both sides, but taking away 5 x's would be a good idea because then there wouldn't be any x's left over on the right hand side there. So it's up to you. I think either adding 6 to both sides or taking 5x from both sides would be good starts. I think I'll take away 5x from both sides, but you could do that in either order. Let's take away 5x. Okay, over on the right, if you used to have 5x and 20, but then you took the 5x's away, you've only got the 20 left. So just the 20 left over on the right-hand side. Over on the left, that's a little bit harder, but you're just collecting like terms. So you have practiced a couple of lessons ago at this. 7x take away 5x is 2x. You've got a minus 6, and there's no more numbers, so it won't simplify anymore over on the left-hand side. So we've got 2x minus 6 over on the left. Notice that taking away x's only affected the total number of x's. It didn't change the number at all. I had minus 6 to begin with, and I've still got minus 6. Okay. Right, now you've seen equations like this. Now notice how we've made the question simpler. To get rid of minus 6, I think I'll add 6, but to both sides. So let's add 6, add 6. Over here, 20 plus 6 is 26, but over here, the whole point of adding 6 is to get rid of the minus 6. So I've just got 2x. And lastly, I'll halve both sides. Let's divide both sides by 2. 2x divided by 2 is 1x. And 26 divided by 2 is 13. So x is worth 13. I've solved the equation. Now the last one really is just for fun. This would throw some of my year 10s, I think, if I gave them this. They wouldn't instantly know what to do. This is just, consider this one just for fun, if you're still with me. This time I'm trying to deal with x's on both sides again. I think I'm going to add 1x to both sides. The whole point of doing that is it means there won't be any x's left over here, because see how it starts with an x being taken away, and the opposite, the inverse of taking away 1x, is to add 1x. So that's what I'm going to do. I'm going to add 1x to both sides. And the whole point of doing that is it gets rid of the minus x's over on the left. So no x's left over here. It's just the 9, just the number 9 on its own. But over here, x plus x is 2x, and there's also an odd 5. Okay, adding x's won't affect the number 5. My next step is going to be, I'm trying to get x on its own. Let's take 5 away from both sides, because you could think of this as saying 2 times the number add 5 is 9. So to get rid of the plus 5, let's take away 5. But from both sides, whatever you do to one side, you must do to the other side as well. 9 take 5 is 4, and we're just getting rid of that 5. The whole point of doing the minus 5 was to get rid of that plus 5. So we've just got 2x left. And now let's divide both sides by 2. 4 divided by 2 is 2, and 2x divided by 2 is 1x.